Here we have a problem on ratio. That is, we have two ratios over here, and we have to find the one which is greater. Okay, whenever I want to compare two ratios and find which one is greater, what I have to do is I have to write both the ratios as like fractions. Okay, here when I look at the first ratio, both the terms are mixed numbers. In the second ratio, both the terms are decimals. Okay, in my first work, what I have to do is I have to convert both the terms of the first ratio to integers. So for that, what I have to do is I have to convert these mixed numbers to improper fractions. Okay, now let me take the first ratio, that is 2 1/3 to 3 1/3. Okay, let me convert each term to an improper fraction. So for that, I have to multiply this 3 and 2. 3 times 2 is 6, and that 6 should be added to the numerator 1. 6 plus 1 is 7. I am getting 7 over 3. So this is an improper fraction which is equal to the mixed number to 1/3. And now let's do the same work for the second term of the ratio. That is 3 times 3 is 9. 9 positive 1 is 10. That is 10 over 3. So this is an improper fraction which is equal to the mixed number 3 1/3. Okay, so if I want, I can multiply or divide both the terms of the ratio by the same non-zero number. When I do so, the resulting ratio will be equal to the original ratio. Here, in both the terms of this ratio, we have the denominator 3. So to get the denominator 3, I'm going to multiply both the terms of this ratio by 3. That is 3 times 7 over 3 to 10, 3 times 10 over 3. Here 3 will cancel. Here 3 will cancel out. I am getting 7 to 10. Actually, this ratio is equal to the original ratio 7 over 3 to 10 over 3. Okay, now we can write this ratio 7 to 10 as a fraction, that is 7 over 10. Okay, now let me do the same thing for the second ratio, 3.6 to 4.8. Okay, now let me write the given ratio as it is, that is 3.6 to 4.8. Okay, when I look at the terms of the ratio, both the terms are decimals. In both the terms, we have only one digit to the right of the decimal point. Okay, now to get the decimal point, what I'm going to do is I'm going to multiply both the terms of this ratio by 10. So that is 10 times 3.6 to 10 times 4.8. So as I said earlier, when I multiply both the terms of the ratio, when I multiply or divide both the terms of the ratio by the same non-zero number, the resulting ratio always will be equal to the original ratio. So when I multiply this 3.6 by 10, I am getting 36. And here when I multiply this 4.8 by 10, I am getting 48. So this resulting ratio is equal to the original ratio. Okay, now what I'm going to do is I'm going to write this ratio as a fraction. Then I'm getting 36 over 48. And now, so both 36 and 48 are the greatest common divisor 12. That is 12 goes into 36 3 times, 12 goes into 48 4 times. Then I'm getting 3/4. Okay, now I got both the given ratios as fractions. So for the first ratio, I got the fraction 7 over 10. For the second ratio, I got the fraction 3/4. Okay, now what I have to do is I have to get both the fractions as like fractions. What is meant by like fractions? Like fractions means you have to get the same denominator for both the fractions. So here the denominator of the fraction over here is 10, the denominator of the fraction is 4. So to get the same denominator for both the fractions, what I have to do is I have to find the least common multiple of this 10 and 4. What is the least common multiple of 10 and 4? For that we have to take this 10 and 4 in L division. What is the greatest common divisor for this 10 and 4? That is clearly 2. When I divide 10 by 2, I am getting 5. And when I divide this 4 by 2, I am getting 2. What is the greatest common divisor for this 5 and 2 other than 1? Other than 1, we don't find any greatest common divisor for this 5 and 2. So now we have to stop the process. We have to multiply these three numbers. So 2 times 5 is 10, 10 times 2 is 20. So 20 is the least common multiple of the two denominators, 10 and 4. That is, we can make each denominator as 20, which is the least common multiple of 10 and 4. Okay, to make this denominator 10 as 20, I have to multiply both numerator and denominator of this fraction by 2. When I do so, I'm getting 14 over 20. Now to make this denominator 4 as 20, I have to multiply both numerator and denominator by 5. So when I do so, I'm getting 15 over 20. Okay, now I got both the fractions as like fractions because both of them have the same denominator, 20. So now what I have to do is I have to compare the numerators. When I compare the numerators, so in this fraction, the numerator is 15, which is greater than the numerator 14 in the first fraction. So when two fractions have the same denominators, the fraction which has a greater numerator will be greater in value. So clearly this fraction is greater in value. That is, this fraction is greater than 14 over 20. So the original fraction which is corresponding to this 15 over 20 is 3.6 to 4.8. So clearly the ratio 3.6 to 4.8 is greater.